we got our boundary conditions, we got our loads, we got our nodes, we got our elements, everything's been applied. So we can go over here and under solution, click on solve and current LS. Go ahead and click there and we'll say okay. And should happen very, very quickly. Solution's done. We'll click close and just go ahead and close this window. By the way, if there's some error and something comes up and things are running like you're expecting them to, go to the other window. ANSYS opens two windows, and this other window, if you find it here, is the output window, and usually it gives a very good description about what's going on, about what happened. So again, nothing's had a problem here, but here's all the explanation of the solving here. And so then if there's an error, just come in here and look for the last lines to understand what happened, and I'll give you a tip to what you need to fix. All right, so we got all of our information. Now we need to go figure out, find the stuff that we solved for. So let's just do a nice little view of the results. So we'll go to plot results, plot the deformed shape. And let's suppose see both the deformed shape as well as the undeformed shape, so we can kind of compare. Go ahead and click OK. And so we got this white dashed line, which is the original position of our truss, and you can see the deflection that happened after the loads were applied. So that's a nice view there. Now we want to get the other actual data from the result. What are those displacements actually? What are the values of those displacements? So I'll come over here, instead of plotting results, we'll list results. And we'll go into the list nodal solutions, or nodal solution here. And we want to look at the degrees of freedom. And we'll look at the displacement vector sum. So this will give you all the components. You know, you can pick individual components up here. We'll look at all the components here. And click OK. It gives you this nice little summary. So you can see that node 1, get this out of the way here. You can see this up bit. You can see that node 1 shows that node 1 did not move in the X or the Y, which is good because we constrained that. That was the boundary condition. Node 2 deflected a negative 0.35 times 10 to the negative 2 what? Right, there's no units given here, so we have to remember what are our units. We're in inches. All right, so node 2, right here, deflected negative 0.35 times 10 to the minus 2, and then x direction, or negative x direction in this case, and also negative 0.10525 times 10 to the negative 1 in the y direction. All right, and you can see what happens for 4 and 5 as well. So that's how we can see the actual values for movement. All right, so that's nice, but now we also want to get some values beyond this. So let's get some stress values. All right, so to do that, let's look at their elements, because that's where our elements show up. So we got the General Postproc, and we'll go to the element table. All right, so down here, the element table, and we'll define table. All right, so we need to define. We haven't defined it yet. So we'll add, and we'll come in here and we'll type in. Again, this is just the name for it. So we're going to say the force, axial force for our label, and you do it by sequence number. And so basically, what this is just within ANSYS. This is how it's defined. So everything you're seeing right now is really just a GUI, a graphical user interface for stuff that you could program into a text file and run in, and ANSYS would solve your model. So when you see MISC, it's the command you would call to actually look at the stresses. So in our case, it's MISC, and then we'll put a 1 here to indicate we're looking at those axial stresses, and we'll go ahead and say apply. All right, and then we'll come back in here, or say axial forces. Those are the axial forces. Now we'll come in here and look at the axial stresses. And again, we'll go by sequence number. And instead of SMIS, we'll do like an LS and 1. So again, this is just how ANSYS defines stress and finding stress and axial force. So we got those two defined. So we'll go ahead and close. And now we'll go back and we'll say element table, plot element table. And we can plot axial force and see what we get there. Right, so we actually see the forces that are in our members. I maybe want to zoom out now. All right, so you can do that with either one. But we also come back in our list element table. We actually want to see the values, and we can just click on axial force, click on axial stress, and then click OK. And it'll give us a table for each element. I want 1, 2, 3, 4, 5, and 6, and it'll give us the actual force. Again, no units. All right, so we got to remember what the forces we were using. So these are all in pounds. And then over here we have our actual stresses. So these are in PSI. All right, so things look good there. All right, so go ahead and close that. And let's look at our reaction forces. So we'll look at our list results, General Postproc, and we'll list results. And we come down here to reaction solutions. And we'll say go ahead with all items. And we can see the reaction forces are at basically the two nodes that were fixed, node 1 and node 3. And we have 150 pounds, or sorry, 1,500 pounds in the x direction and negative 1,500 pounds in the x direction. So at node 1, right, we can see it's the reaction force is pushing this way, right, which makes sense because it's going downward here, so it's going to be pushing into the wall. So the reaction is a push back. And at 3, it's pulling away from the wall, so 3's reaction is to pull back. So it's a negative 1,500 pounds. All right, so that's how we solve it. If you have any questions, you put them in the comments. Try to answer those. Otherwise, as you finish up, again, make sure you save DB. And so that actually means saving to a particular file. Let's save our overall analysis. Come up here and save as. Make sure we know it has been saving it to some random file, so make sure you can save it to where you want. So I'll just save it under mine, basic things. So we're going to call this Truss DB. It looks like I'd already saved it before. Okay, and go ahead and replace that. All right. So hopefully that gives you a nice overview of ANSYS. Again, I'll do the second example in the next video, and you can check out another way you can work on solving that. All right. Thanks.